for the interesting talk.
Okay, thank you.
Now we shall proceed with the next talk by Roman Dushkin.
Yeah, thank you very much. I present to you our paper and thesis, which has
Can you share your screen?
I'm sorry. I'm very sorry. We didn't prepare any presentation for it,
Oh,
but I will show you some ideas about our paper in live mode, perhaps. So I present the work from Moscow Engineering Physics Institute, which done, and Moscow Agency of Artificial Intelligence, which is done by me and my colleague Vladimir Stepankov. So we present yet another criticism of Chinese room from the position of hybrid model of hybrid architecture of artificial cognitive agents. So let me just demonstrate you some ideas which I will draw with my tablet. Okay, all what I want to explain and tell you is about the same theme: understanding of what we see and what artificial agent perceive. So I continue the previous and pre-previous themes, and all this about symbol grounding problem. So what is symbol grounding? If we think about something, then we see with our inner eye some images or hear some sounds or something like that, because all our symbols are grounded into sensory systems, basic sensory systems. So we in our laboratory solve this symbol grounding problem with very interesting idea. Before I explain how we solve this symbol grounding problem, I will show you our idea about general cognitive architecture. So we have sensory systems, different sensors which perceive information from the environment. Then we send all this information into multi-sensory integration system. Multi-sensory integration. The purpose of this system is to build the holistic description of perceived scene, and then this holistic description goes to two controlling systems: reactive and proactive. And this subsystem they communicate with each other, and these subsystems communicate also with knowledge base. Knowledge base which consists of personal experience, personal life experience of this agent. Then all these systems send the signals to motor system, which translate the signals, the high order signals, high order commands into very low-level signals, which something like assembly language or machine code language in computers. And these low-level signals goes to actuators, which conduct this response cycle to environment back. And this cycle of operation is done continuously and perhaps in concurrent mode with itself, because it is really continuous. So the human being is operating something like that. So how we use this general architecture to solve the symbol grounding problem? It's very tricky thing. So all stuff goes through this system of multisensory integration. If we, for example, let's consider one simple thing, a table. A table, like an object which is always considered in such circumstances. So we can see a table, we can hear the sounds which I say table, and we can even see the inscription in different scripts and so on. This is seen by us, this is heard, this is seen again, and all this stuff goes into this system, multisensory integration system, and we do something like that, like this. We have a space of visual symbols of tables, different tables in different positions and rotations and so on. We have a space of sounds which are made with different amplitude, voices and so on. We have a symbolic space, which is something like inner symbols of our concepts. And here we have a symbol of table. And then through this system of multisensory integration, we do a grounding of this symbol into one concept. So, what are the main position of our criticism of Chinese room? John Searle, when he proposed this well-known thought experiment, he think that this Chinese room is something like tabula rasa, yes. And when we input here something like this, or something like Zhuozi, it has no any sense of what it is. I think if anyone from you don't know Chinese, you too don't understand what this means. But perhaps you can think that this is exactly the table in Chinese. So how to solve this strange situation? Why Chinese room doesn't have any sense of meaning of these strange characters? So, because there are no associative links between any symbols of concepts in its mind or knowledge base with these particular symbols. And if we took this Chinese room and put it in mode of learning, then we will make an interesting process. We will take these Chinese squiggles and squaggles and make an associative connection to this symbol from symbolic space. Perhaps it will be connected at first. The sound of these symbols will be connected to audio space, and the inscription will be connected to symbolic space. And then when we study Chinese language in very intensive way, this symbol will be connected to directly to concept, and then it will has different associative links to all symbols which are to which this concept is grounded. And through these symbols and through this space, through this concept, it will be linked with other concepts in agent's knowledge base. So it will be perhaps how it will be in English. I know German word, Möbel, yeah. Maybe. So
Furniture.
Furniture. Yeah. Furniture, yes, of course. Perhaps other concepts and so on. We will have very dense network of concepts in this knowledge base. And when this Chinese room is trained, is taught by such a process, which is analogous to how we train human babies, it will understand these squiggles and squaggles, as John Searle said, because it Chinese room will have these strong connections with conceptual symbols in its knowledge base. So this is the main idea, which is explored by us, by our collective in our laboratory, and I hope our paper which we published at this conference and all other papers which we already published in other conferences will be a subject of interest for you. So thank you very much. I hope my live presentation was not very boring for you. I'm ready for your questions. Thank you.
That was really innovative. Okay, please, questions.
I have a question. Roman, there is a possible version of the Chinese room argument that we should imagine it like the multimedia Chinese room. And in this case, instead of sending just symbols in Chinese, you also send videos and images of the objects of the world that you want to represent. And well, in this case, you are able to generate a better understanding of things that are not just symbolic, but also are iconic in the sense that they are icons of the things of the world. How do you think that your argumentation could connect with this idea of the multimedia Chinese room?
Yes, I think we continue this argumentation because we introduce this multisensory integration subsystem of cognitive architecture, and through this multisensory integration subsystem, all that iconic representations of symbols are connected with each other, and we talk not only about the images from video sensors, but we talk about any other different sensory modalities. So just in this, you can see that we extend that argument of multimedia Chinese room, and just now we use it in our work.
Okay. Thank you.
Hedda has a question. Hedda.
Oh, sorry. If I can maybe give a little bit different perspective on the philosophical argument. So for us as computer scientists, a network of concepts is maybe the same, and then you add in pictures from all sides and so on, and we have this idea. You have a connection, and you have all these ideas connected. You have all these images, sounds, and so on connected, and you have this connection graph. And we have this idea. This is meaning. And then we don't really understand what Searle's problem is. But if I may go back to, I don't remember, was it Adam who said it, that if you take the introspective approach, which is not popular at the moment, but was so for about 2,000 years and longer, you have the idea, if you look at something, or if somebody tells you something like, let's say, I killed a person driving over in a car accident. Then you say, oh my goodness, yeah? You have a meaning of, you know what it means. So and the same for other, events, persons, and so on. This introspection. So if you look into yourself, and then you think about the objects, then you have a sense that there is a connection between you and the object. So this is what philosophers talk about when they talk about symbol grounding. We as computer scientists, we have accepted, okay, we're just computers, so all we are actually doing is we are some sort of network, we are network connections, and then what's his problem? It's just a matter of association of words with images and so on. But for the philosophical perspective, and the philosophical perspective is a lot wider than our idea of computers or the human mind as a computer. That's kind of our basic axiom when we're talking here. So we can't really talk to Searle in that manner, because what Searle is talking about is a lot wider than what we're talking about. Philosophers talk about ontologies. When we as computer scientists talk about ontologies, we mean networks of concepts. When philosophers talk about ontologies, they mean the immortal soul, God, the universe. Yeah, so you have a very different perspective at the world, and you can't tackle Searle's argument with a computer metaphor. I'm just trying to explain what the main misunderstanding is between many computer scientists and what philosophers mean. Philosophers mean there is a connection between the one who means and the object meant, a real connection in the world. And so that's a little bit more than what we mean by it. Okay, that's just my comment.
Thank you very much. Very interesting, but I'm just a practical scientist which don't use any metaphysics in my works. But thank you.
Artemy first, he had her hand previously.
Thank you. Roman, if the symbolic system brings to you the Georgia, which you cannot interpret, and a visual system brings you another character, which is the representation of this video representation. You connect one to another, but you still cannot understand what is in reality. This is, as I understand, this argument.
Mm-hmm. Exactly.
What to do with that?
Exactly.
What to do with that?
This is a very subtle thing, and I don't want to do a great discussion right now, because it's just a half an hour after midnight in Moscow. So I'm sorry, Artemy, I will send you our new work about this when we propose the process which we call semantic supervised learning, which is used to resolve such a situation. I hope so. In short, if we try to connect different symbols which have various modalities, we will consider this situation just like a human babies. What if we show to a little child who has no any meaning in its head about different objects of the world? If we show them something like toy cars or some other toy, for example, toy car, and we will name it this toy, for example, human. We show toy car and name human, and we will form a connection in their head between iconic representation of a car and a tonic representation of our voice with the word human. But we will not still form any conceptual symbol in their head, because the concepts, the symbols will form only after we have trained this whole system on very lots of examples, and after generalization of various things, of various objects, of various sounds, and so on, we will form different conceptual symbols in their knowledge base. But when we design the artificial agent, we could skip this process, and we can pre-program some symbolic network for more exact symbol grounding. Not just we we need not train such an artificial agent from the zero ground. I think so.
非常感谢。
Excuse me?
非常感谢。
Ah,
Thanks a lot. Chinese.
yes, yes.
Okay, Howard.
I think Roman, thank you for the talk. I really like the writing. I enjoy those talks more than slides. I miss people on blackboards writing things, and so I like that.
I have just a table for such a purpose.
Tablet, yeah, I really liked it. It captures attention much better than slides. I really like that. Two things. One, there's the grounding problem, which I'm not going to talk about. I have my own ideas. What you talked about in terms of the grounding, there's Harnan from the 1990s. He said almost the same thing you did about Searle's thing. He talks about having a dictionary, learning another language. You don't know the first language. I think my own feeling is I think Harnan, Searle, they're all wrong mathematically, because I don't think things necessarily have to be grounded for it to work, but that's a whole nother discussion. Just like if you give me a bunch of data, I can use methods from Pearl the last 20 years to change statistics. I can find causal relations even if I'm not grounded, but that's a whole nother discussion. My issue is this. The other problem, there's two problems. There's grounding, and then there's the binding problem. The binding problem I spoke about this morning. I tried to do what you did last year, and it won't work, what you're showing. You're going to have problems with fusing everything into that center, and then that center, you're going to have to make decisions from it. It's not going to work. You're going to get combinatorial explosions, and it won't work. It'll work if you can fuse something very simple. For example, in a self-driving car, if you have 8 cameras and they're all video cameras, you can fuse the video cameras for one visual image. You're going to have a hard time fusing everything the way you're doing it. You have to account for the binding. You somehow have to bind the information in a way that's, I think, a little bit more mathematical that'll work out. I don't think it's going to work what you showed.
Yes, it's a known problem. We just now carry out some experiments about this and try to find the method of how to say the method of choosing the right action, because we think that the main purpose, the main goal of symbol grounding is to choose the right action of agent, and we just now tell about embodied embodied agents in our reality. So if we of course, if we have a very broad network of concepts, and we will fire any associative link between them, we will very quickly go into combinatorial explosion. So we just now we are searching for this method of something like binding the context into a current situation. Just now I can't say anything exact about this, just because we just carrying out the experiments.
Okay, I have the same problem, that's why. But I think there's two issues. One is grounding, the grounding issue. And there's people, Searle, Harnan, Barcelo, who write about it. I don't think they're right even, but that's a whole nother issue. Harnan, 1990, he wrote about trying to learn another, he said it's a better example of trying to learn another language. It's Harnand, Harnan. He gives almost the same example that you gave, Harnan. I'm learning another language. Then the other issue is the binding problem. I think they're separate problems. And the binding problem is very challenging because the combinatorial explosion you get.
Yes.
But I enjoyed the talk very much. It's late. Thank you for a wonderful lecture.
But I think this problem is not unresolvable, because we people we have some methods of resolve it. and I see something like lazy programming, lazy computation from functional programming, something like that.
Mm-hmm. There are lots of ways to solve it. There's always solutions, but I think you have. The problem is you have to look for some subset that you want to solve. What I was saying before, there's an equation of general intelligence from I could put it'd be better if I put it on the screen, from Legg and Hutter, 2008. The problem is it uses Kolmogorov complexity. Once you have Kolmogorov complexity, you can't solve things. It's everything. You have to, for any of these problems, you have to pick some sort of subset exactly if you want to solve it. You have to do that, which is what I'm doing now in my own model.
Exactly.
Yeah.
Thank you.
Yeah. So, thank you.
Okay, thank you, Roman, for your talk. I guess we exhausted all available time and we need to move further.